Well, it's amazing to be joined by James Munday, part of the KXC family. Soon to be Dr. James Munday. Very exciting. That's on the horizon for you. Just finishing off the PhD. So, James, obviously we've all read a little bit, but we've all read enough to consider ourselves experts in COVID-19. I've read a couple of articles now, and I feel good that I'm fully in the know. And I'm obviously joking, but it is such a gift to chat to someone who is an expert. So, James, your job title is that you're an infectious disease epidemiologist. For the mere mortals amongst us, explain what that actually means. What do you do?
So basically, I study the dynamics of infectious disease transmission, so mostly with maths and statistical models. So our job is essentially to take the data that you'll see published on the news or whatever, and we convert that data into information about how the pathogen is spreading, and then we can try and make inferences about how effective interventions are or where we expect the transmission to go in the future.
So when it comes to corona then, you recently mentioned that it's a family of viruses. That was news to me. Just explain that.
So, yeah, essentially it comes from coronavirus. So SARS-CoV-2 is the specific pathogen in this case. And it comes from a family of viruses, so basically like the same species. Being infected with these different viruses will have a different impact on your body. And so a lot of coronaviruses are really harmless. And actually you all have had coronavirus in the past, and it would have look like the common cold. It's kind of one of the viruses that we might call the common cold. There are other more severe coronaviruses such as SARS, which there was an outbreak of in 2003, and there's also one called MERS, which is Middle Eastern Respiratory Syndrome, which is it's quite severe, but it mostly transmission mostly occurs between camels and humans, so there's not a huge amount of human to human transmission.
So then the one that we're facing right now, this crisis we're facing right now, I mean, your job is to essentially assess the spread, but there's a few key questions you're working on. Just talk us through those.
Yeah, so my team are looking at, you might have heard of the basic reproduction number, which is essentially the number of infections that are caused by each infected individual in the population. Now, the basic reproduction number of a disease in normal kind of operating society is used for developing vaccinations or vaccination campaigns to ensure that we vaccinate the right number of people. And what the idea is that you can change the reproduction number by either vaccinating the population to invoke immunity, or in this case by changing behaviour. So if you reduce the number of contacts you have over the course of a day, then the number of people that you are likely to infect is reduced, and therefore that reproduction number changes over time, hopefully decreases. And so my team are tracking that reproduction number in every country in the world that has sufficient cases to do so at the moment, and then in a few kind of cases subnationally. So in the UK, we're looking at regional estimates as
now,
well.
you mentioned the V word, vaccine. We're all desperately hoping that the vaccine will come soon. Just briefly tell us, what is the process of finding a vaccine, and how far along that process are we?
Yeah, so I mean, it's an incredibly complicated process. Essentially, there's sort of like 4 stages to vaccine development. The first stage is developing a candidate vaccine, so something which science would say will invoke that response, the immune response that you want. So that's done in a lab, kind of typical like petri dishes and stuff. Once you have the candidate, there's basically 3 questions that you need to answer in order to make in order to support that vaccine for a license. So those are: is it safe? Does it develop an immune response? And then thirdly, is that immune response sufficient to protect against the actual pathogen? And so each of those questions is answered effectively in a different stage of the vaccine trials process. So the first stage is testing in animals, and then testing in a small number of humans, just to check if it's safe. Then it's testing in a larger number of humans where you can measure the immune response in the body. So you're not testing against protection, you're just saying, is the immune response being developed? And then thirdly, it's distributing into a large population to test whether it's actually effective in protecting against the pathogen. So it needs to be in a context where there is an outbreak.
Where are we in that process?
Yeah, so currently there are a few candidates out there. My understanding is there's 2 that are in that first stage of testing. So there's one in Australia that's been tested in rodents, and one in the US, which is, I think they've gone straight to testing in humans. So it's a hugely complex operation, and it involves hundreds, if not thousands, of scientists from multiple disciplines. There's a huge amount of focus on this, and if these candidates, so the challenge is that a lot of candidates will fail in vaccine development, and there hasn't been a coronavirus vaccine before. So this would be the first ever coronavirus vaccine. But if these candidates work, then we're talking about, setting records for development time. There's a lot of focus on this.
And then in terms of, we as followers of Jesus, we're praying right now and praying for that process. And, for some people, they think that, the answer to prayer will be some sort of supernatural intervention and here's the vaccine. And it may well be, we believe in miracles, right? But the likely answer to the prayer is that God's actually in the process of these scientific breakthroughs that lead to a discovery. So like practically then, you're a scientist, you're a follower of Jesus. How can we be praying for the scientific community in trying to find this vaccine?
Yeah, sure. So I think the key thing is stamina. Like in my field, we've been looking at this since January already, and it's been our lives since then in terms of work, and people are working incredibly hard. And so this is going to be a long slog, and I guess, just that we as a community are able to deal with that. Something that probably scientists aren't really used to in terms of having so much focus on them. Secondly, I think grace, both within the community but also towards the community. I think the challenge is that scientists are often depicted in the public eye as either heroes or villains. So, we're heralded as the people that will bring the answer. And then if that goes wrong, then there's lots of questions about whether the right things were done. And so it's completely at odds with science in the sense that the scientific mindset, the scientific worldview is actually the opposite of that. It's really just you progressively develop something, and you're not a hero, you're not a villain, you're just developing, you're just slowly doing something and you're doing it well. And I think that, so that's really challenging for the community when there's so much focus on the community at the moment. And then I guess finally, inspiration, breakthrough, that we'd be looking in the right places. The vaccine candidates would work, but also that we'd be, identifying the correct response. It's not a straightforward task in terms of deciding or kind of advising on what restrictions should be in place, and that's a real challenge.
James, you're a legend. That was so fascinating and so grateful for your time. And we as a church celebrate, honour what you're doing, and we're praying for you and the scientific community for grace, as you said, for stamina and for a breakthrough. So, Godspeed to you, mate. God bless.
Cheers.